In lecture number 2, we studied calorific value and its determination of a calorific value of a solid or liquid fuel by using a Bohm's calorimeter experimental method. And also we have solved some numerical problems on determination of calorific value of a solid or liquid fuel by using Bohm's calorimeter experiment. In today's lecture, in video lecture number 3, let us begin knocking in petrol engine. Knocking means unwanted sound. How to define knocking? Knocking is an explosive combustion of fuel, means petrol or diesel, and air mixture in an IC engine produces a shock waves. When it hits the wall of the cylinder and piston, produces unwanted sound is called rattling sound, is simply known as knocking. So in an 4-stroke internal combustion engine, take an example of car engine or your general petrol engine. There are 4 strokes are taking place in an IC engine. The first stroke is intake or suction stroke. In this, the piston moves downstream dead end where air and petrol mixture has been drawn from the outside to the IC engine. In second stroke is called compression stroke, where piston moves off dead end where air and petrol mixture gets compressed and then ignited by the sparking plug. Third stroke is called power stroke, where piston moves downstream dead end by exploding air and fuel mixture in an IC engine. The fourth stroke is called exhaust stroke, where piston moves upward deadstream where spent gases are pushed out through the exhaust system. So this is the figure. It shows the important parts of engine, where you can observe there is a closed cylinder fitted with frictionless piston with crank, and it has combustion chamber, intake valve for air and petrol, exhaust valve for the release of flue gases, and there is a spark plug for the combustion of the fuel and air mixture. Under normal combustion, where the petrol and air mixtures combustion smoothly and rapidly. As a result, flame spreads rapidly and smooth, creates a pressure on piston. As a result, functioning of vehicle starts. Under abnormal condition, due to presence of free ignition in an IC engine, there is a formation of unstable peroxides which acts as a chain carrier, creates enormous pressure, and when it hits the wall of the cylinder and piston, produces the knocking. In an internal combustion engine, mixture of gasoline vapor, means petrol, and air are used as a fuel. After the ignition of the combustion reaction by spark plug in an cylinder, the flame should spread rapidly and smoothly through the gaseous mixture, thereby expanding. Gas drives the piston downstream dead end of the cylinder. The ratio of the gaseous volume in the cylinder at the end of suction stroke to the volume of the cylinder at the end of compression stroke of the piston is known as compression ratio. Therefore, compression ratio is equal to volume of the cylinder at the end of suction stroke to the volume of the cylinder at the end of the compression stroke, as I explained in the previous slide. The efficiency of internal engine increases with increase in the compression ratio. Compression ratio increasing, it increases the efficiency of the engine, and also more power is also obtained from the engine. This is totally dependent on the nature of the constituents present in the petrol what we are using or the gasoline, and also the condition of vehicle how we are going to ride it. In certain circumstances, due to the presence of some constituents in the gasoline or petrol, the rate of oxidation becomes so great that the last portion of the fuel and air mixture gets ignited instantaneously, produces an explosive violence sound after hitting with the piston and wall of the cylinder, known as knocking. Therefore, knocking results the loss of efficiency of the engine. So, knocking mechanism, how we can explain in terms of chemical terms. Let us discuss when the vehicle is running under normal condition. There is a smooth oxidation of the fuel. It involves the following reaction, where sufficient oxygen molecules combines with limited amount of hydrocarbon molecules, means petrol. For an example, ethane, there is a leading of formation of carbon dioxide and water with energy. In this chemical process, under normal condition, there is a use of limited petrol molecules and sufficient air or oxygen leads to produce the stable products. Because of there is a formation of stable peroxides are leading to decompose to form the stable products like carbon dioxide and water when the vehicle is rides in the normal condition. Under abnormal condition or explosive conditions, the rate of combustion is very high. It involves the following steps, where the oxygen combines with hydrocarbon molecules, means petrol, forming the peroxides. In this process, what we can explain, where more amount of petrol molecules are combining with the limited amount of air or oxygen, leading to form the ethane peroxides or unstable peroxides. So these ethane peroxides are unstable, readily decomposes to form the acetaldehyde. Acetaldehyde further oxidation leading to form the formaldehyde. Formaldehyde further oxidation leading to form the water and carbon dioxide. So, formation of unstable peroxides of gaseous products, which will increase the rapid pressure inside an IC engine. When it hits the wall of the cylinder and piston during the combustion, leads to knocking in IC engine. So what are the problems to the engine if there is a knocking is taking place? Let us discuss now some of the ill effects of knockings are: number 1, carbon deposits on liners of the engine and combustion chamber. Second one, mechanical damages to the cylinder as well as the piston and spark plug. There is an increase in the heat transfer. There is a production of noise or loud or rough sound from the engine. There is a decrease in the power output and efficiency of the engine. There is a chance of pre-ignition of the fuel and air mixture. Then driving and traveling becomes unpleasant if there is a knocking is observed. Then remedies to control knocking in an AC engine. 3 important ways how we can reduce the knocking are as follows. The first one is by using high quality of gasoline or petrol, or second one is by adding anti-knocking agents which are reducing the knocking tendency of the fuel, or by adjusting critical compression ratio in an IC engine. So now the quality of the petrol depends upon its chemical structure. Hence knocking is also dependent on the chemical structure of the hydrocarbons present in the petrol. The tendency of fuel constitutes a knock is directly related to in the following order. Let us see in this expression. If you have the straight chain hydrocarbons in the petrol are in more number, are leading to produce more knocking or loudness as compared to branch chain hydrocarbons are more noisier as compared to olefins or alkenes, are more noisier as compared to cycloparabenes or cycloalkanes, are more noisier as compared to the aromatics. So as this flow order of nature of hydrocarbons, it is observed that straight chain hydrocarbons are more louder or noisier if you use in an IC engine as compared to if the petrol is containing more number of aromatic hydrocarbons are least noisier. Thus what we can depict, the olefins of same carbon chain length possess better anti-knocking character corresponding to the parabens, means open chain hydrocarbons of same carbon length, and so on. The knocking is maximum in open chain straight parabens, that is straight chain hydrocarbons, and which is very much least noisier if the hydrocarbons are in aromatic natures. Therefore, the quality of petrol, if it is to be decided good one, it should have more number of aromatic hydrocarbons as compared to the straight chain hydrocarbons which are leading to produce the least knocking characters. Now let us discuss about the assessment of quality of petrol and diesel. The quality of petrol can be assessed by the parameter is called the octane number or octane value or octane rating. So what is meant by octane number? Before that, to discuss the octane number, let us have the introduction about the octane number means what. octane number is the grading parameter to assess the quality of the petrol used in the petrol engine, which relates directly to the knocking character of the petrol. It is observed that normal heptanes always knocks very badly. Therefore, its anti-knocking character or value is arbitrarily fixed to the 0. Whereas iso-octane hydrocarbons are knocking very least. Hence, their anti-knocking value is arbitrarily fixed to be 100. Let us see in this slide I have mentioned two hydrocarbons. One is 2,2,4 trimethyl is called iso-octane, whose octane value is arbitrarily fixed to the 100. It is a branch chain hydrocarbon, hence it knocks very least. Its octane value is arbitrarily fixed to the 100. In another side example, we have mentioned N-heptane, which knocks very badly, and its octane value is what? Arbitrarily fixed to the 0. Now let us define what is the definition of octane number means what. Octane number of a fuel is defined as the percentage of iso-octane present in a mixture of iso-octane and N-heptane which has the same knocking characteristic property as that of the petrol under the test. Or the same definition how can define octane number is defined as the percentage of iso-octane present in the standard mixture of iso-octane and N-heptane which has the same knocking character or compression ratio as that of petrol under the test. So, as we have studied in the previous slide about the structure of the hydrocarbons, iso-octane is the branch chain hydrocarbon, has least knocking rate, hence its octane value is taken as 100 value, whereas normal heptane is the straight chain hydrocarbon, has highest tendency to knock, hence its octane value is fixed as 0. Let us take an example of how to predict the octane value of the given petrol which we are using from the petrol bunk. If the petrol octane value is rated as 80, it means what? That petrol has the same knocking character as the mixture of 80% volume of iso-octane and 20% volume of N-heptane composition. The octane number decreases in the following order. Aromatics are least noisier, they have got higher octane value. Alkenes have got more noisier, have got least octane value. Hence octane value is going to decrease in this order. Aromatics have got more octane value as compared to alkenes. Alkenes have got more octane rate as compared to branch chain hydrocarbons. Then branch chain hydrocarbons have got more octane number as compared to cycloalkanes, and cycloalkanes have got more octane value as compared to the N-alkanes. Means this is what octane value is what decreases. Aromatics have got more octane rate as compared to alkenes. Alkenes are what more octane value as compared to branch chain alkenes. And branch chain alkanes have got more octane value as compared to cycloalkanes, and cycloalkanes have got more octane value as compared to normal alkanes. Now let us discuss how to decide the quality of the diesel oil. Diesel oil quality is assessed by the use of cetane number. So cetane number is the grading parameter for the diesel engine fuel. That is what diesel. It is based on the ignition delay. It is observed that the hydrocarbon cetane, that is N-hexadecane, is called as cetane, is a good diesel engine fuel. Its value is 100 assigned arbitrarily, whereas alpha methyl naphthalene has a longer ignition delay, hence its cetane value is arbitrarily fixed to the 0. Then how can define the definition of cetane number means what? Cetane number of the fuel is defined as the percentage of cetane present in the mixture of cetane and 2-methyl naphthalene or alpha methyl naphthalene which has same ignition delay as that characteristic of diesel oil under the test. It is also defined as the percentage of cetane present in the standard mixture of cetane and alpha methyl naphthalene which knocks at the same compression ratio as the diesel fuel being under the test. Thus the fuel with cetane value number 8 means what? 80 means what? Thus the fuel value cetane number with 80 means what? Which has got same knocking character as that of 80% of cetane and 20% of alpha methyl naphthalene. The cetane number of the diesel oil decreases in the following order. The cetane value is more for the normal alkanes as compared to cycloalkanes. Branch alkanes are more as compared to alkanes and more for the aromatics. Okay. So here cetane number value is what? Decreases. Cetane value is more for the normal alkanes and is less for the cycloalkanes, less for the branched alkanes, less for the alkanes and very much less for the aromatics. So from this what we can conclude, if you want to say the petrol oil is good one, it must have the more aromatic hydrocarbons as compared to the other rest of the hydrocarbons. If you want to say the diesel oil is good one, it must have the long chain hydrocarbons, normal alkanes as compared to the other hydrocarbons. So then how to improve the anti-knocking character of the fuel? So anti-knocking character of the fuel can be improved by using the anti-knocking agents. If the petrol or diesel, if they have got more knocking character value, then how to make them, how to improve the quality of the petrol and diesel oil? We need to use some chemical agents. They are reducing the knocking character. They are termed as anti-knocking agents. So let us define anti-knocking agents in precisely. These are the substances which are added to the petrol or diesel in order to prevent knocking in IC engine. Or anti-knocking agent is a chemical substance that is added to the petrol or diesel to improve the anti-knocking property. So anti-knocking agents for the petrol engine. For example, tetraethyl lead. In short form, you can write it as TEL, and its formula is C2H5 4 times Pb. Tetramethyl lead. In short form, we can write it as TML. Its formula is CS3 4 times Pb. Whereas mixed ethyl methyl lead, that is methyl tertiary butyl ether, is one more examples for the anti-knocking agents. So amongst these, tetraethyl lead is widely used since it is cheap and effective to increase the octane number, and addition of TEL to the petrol increases the octane number of the petrol oil. Tetraethyl lead is normally used along with ethylene dibromide or ethylene dichloride.